Good morning, 8th grade. We are going to go ahead and get started on the next section of Chapter 7. And it's all about rational exponents, meaning exponents that are in the form of a fraction, and what we call radicals. We've seen these before. You might not recognize the word, but we have seen these before. So, a radical is going to look something like this. I'm going to write it in variables, but all the ones we see are going to have a mixture of variables and numbers in them. So, an example would be, so we would read this as the n root, there we go, the n root of a. So what this means is, this here, the n, is what we call the index. And I'm going to highlight those the same color. Okay. The n is the index. This is the nth root of a. The index tells me, so for example, if I was doing the square root of a number, I would break it into two numbers, a number times itself, to get whatever was in the middle. If this was 3, I would break it into a number that could be multiplied by itself 3 times. So essentially, this number here, the index, tells me how many pieces I'm breaking this into. So I'm just going to say, how many pieces, quotation marks, how many pieces the radicand, that's what this number is, radicand is broken into. Okay, and that leads me into the next one, which is our number that is under the square root symbol, and we call this the radicand. And this is the number that is kind of being broken into however many pieces. So number being broken up. Okay, now before we, and let me highlight this pink. There we go. Now before we actually get into any of these, I just want to remind us of something real quick, because I did talk about it back in section, which one was it? I think it was the very first section that we did. We talked a little bit about rational exponents, but very, very briefly. So I just want to remind us, if we have something like this, let's say we have 25 to the 2/3 power. Okay, here is what this means if I was going to write it as a radical. That's what the whole thing is called, by the way, a radical. So it would be this if I wrote it as a radical. The numerator stays with this guy. He stays with him, and this is how many pieces he's being broken into. So the denominator is our index. So this would be the 3rd root of 25 squared. Now I could go ahead and write out what 25 squared would be, but I just want to leave it like that so you can see where everything is going. So I'm actually going to highlight these. Okay, so your denominator is always your index, and your numerator, I should do this in a different color. Let me get this one. Your numerator is your exponent that stays with your radicand. Okay, and then 25 is your radicand. Okay, just so you can see where everything is as we're doing these. So, first thing we're going to do, we're just going to practice a couple of these guys, and then we will get into some more complicated stuff. All right, here we go. So, I'm going to go to the top of a new page. I'm going to put a 1. And the first thing we're going to talk about is finding roots. Okay. So, first one we're going to write down is this. My chair over a little bit. Move this a bit closer. There we go. All right. So let's do 125 to the 1/3 power. Okay. Now, what this means is this is the third root of 125 to the first power. Now, since it's to the first power, I don't actually have to write it under the radical symbol. I can just leave it as the third root of 125. So you want to think to yourself, there's a number that if I multiply it by itself 3 times, it will give me 125. So what would that be? Well, that would have to be 5. Because if you do 5 times 5 times 5, that would give you 125. So the cube root, or the third root of 125, is 5. You don't have to do this step. I just sometimes like to write it out so you can see where that 5, or whatever the number is coming from. Let's try another. How about the 16 to the 1/4 power? Well, if I were to write that out as a radical, it would be the fourth root of 16. So it's a number times itself 4 times. That would give you 16. So what would that be? That would have to be 2. Okay? Let's try one more. This one's going to be a little trickier, and I'm going to show you what we're going to do with it. 64 to the 3/2 power. Okay? Here's what this actually means. It means the third root, or sorry, the square root of 16 to the 3rd power. Now, you could go ahead and plug that into your calculator and be done with it, or we can use our mental math, and that's what we're going to do. Remember, when you are multiplying powers that have the same base, you add the exponents. So I'm going to think of 64 to the 3/2 power as 64 to the 1/2 times itself 3 times. Because think about it, if I were to multiply these, it would be 64, I'd keep the same base, but I would add 1/2 plus 1/2 plus 1/2, and that would give me 3/2. And this might be a little easier to figure out because remember, the 1/2 power is square root. So this is really like the square root of 64 times itself 3 times. And we know the square root of 64, that's going to be 8 times 8 times 8. So, oh wait, hang on a sec. That should be 64. Sorry about that, guys. I don't know why I wrote 16. Anyway, so 64 to the 3/2 power is the same as 8 times 8 times 8, which I believe is, what was it? Yep, 512. 512. And there you go. Now, you do not have to write this out every single time. This step might be helpful to write. You don't have to write the square roots. If you know that 1/2 power is the square root, you don't have to write that out. But it is helpful sometimes to think, how can I break up this fraction into, something that I can easily recognize? Because if you can do that, you can make it much simpler for yourself. And you don't have to go and get your calculator. All right, let's try some more complicated stuff. Here we go. Oops, I apologize. All right, so what we're going to do basically is we're going to be converting between what we call exponential form to radical and radical to exponential form. So we're going to convert to radical first. Convert to radical form. That means when we are converting to radical form, I should see some sort of radical sign in there. Okay? Let's give this a shot. we'll start off nice and easy. We'll do 12a to the 2/3 power. Okay. Now, keep in mind, this 2/3 only applies to the a. Why? Because there's no parentheses. If there are parentheses around this, it would be to both of them. But since there's no parentheses, I can only assume that this 2/3 applies to what is directly under it, and that is the a. So I'm going to think about this as kind of like two separate things. I'm going to think about this as 12 times a to the 2/3. Okay, I'm going to think about it that way. Because if I do that, then I can write a as a radical. So it would be 12 times, remember, denominator is our index, numerator stays with the radicand. And then I can even get rid of this multiplication symbol and just write it as 12 cube root of a squared. Okay, so this converts to that. Couple steps in between. All right, that one wasn't so bad. Let's try another. All right, here we go. Let's do 5x to the 1/5. Now again, same thing here. Since there are no parentheses, I can only assume that 1/5 applies to what's directly under it. So this 1/5 only applies to the x. So again, I'm going to think about this as two separate things for right now, just so I can do this a little easier. I'm going to think of this as 5 times x to the 1/5. Okay? Because once I do that, I can write this as a radical. So 5 times the 5th root of x to the 1st. And I'm just going to clean it up a little bit. I don't need the multiplication symbol because if they're next to each other, they're being multiplied anyway. So 5 times the 5th root, and since this is the 1st power, I don't have to write it. It's understood as to the 1st power. So 5x to the 1/5 becomes 5/5 root of x. Okay? Good so far. All right. Let's try another. This one's going to be a little tricky, but that's okay, because we're smart and we can do it. Here we go. Now there are parentheses. 64a, all of that to the 4/5 power. Okay, now since there are parentheses, this 4/5 applies to everything in here, the 64 and the a. Now, here's where it gets tricky. I want you, when you see parentheses, I want you to focus on the denominator, because that's basically going to become your index. And your index tells you how many pieces you're going to break up everything into. Okay, so since this is a 5, that means I'm going to end up having a 5th root. Kind of like what happened in the one just above. It was a 5, we had a 5th root. This is a 5, it's going to end up being a 5th root. Now I want you to think to yourself, 64, which is the number we have here, cannot nicely be broken up into 5 parts. I could do it. I'm going to get some nasty fraction, or sorry, decimal, and I don't want to do that. Okay? So I want to think to myself, is there a way that I can take 64 and maybe break it into something where I have a number that can be broken up into 5 pieces? Because I'm noticing, if I were to rewrite this, I'm noticing that 64, can I write that as 32 times 2 times a? Because I notice 32, that can very nicely be broken up into 5 pieces. Okay? So here's what I'm going to do. I'm almost going to, actually I shouldn't have written this multiplication symbol. Get rid of that. I'm going to almost treat these as 2 separate things now. I'm going to take 32 to the 4/5 and I'm going to take 2a to the 4/5, and I'm going to deal with them on their own. So here we go. So this would be 32 to the 4/5 power times 2a to the 4/5 power. That's still in parentheses because that 2 is also getting raised to the 4/5 power. Don't forget that. Now, this, I could just go ahead and plug it in my calculator and be done with it. But we are smart. We're going to use our mental math because I know if I have a fraction like this, I can split it up into its unit fractions. I'm going to split up 32 because I have 32 to the 4/5. Can I think of that? Is 32 to the 1/5 times itself 4 times? The answer is yes. Yes, I can. Because I know this is like 32 to the 5th root of 32. And what's the 5th root of 32? Think, it's something times itself 5 times to get 32. That's 2. Okay? So now I can rewrite this 32 to the 4/5 as 2 times 2 times 2 times 2, which would be 16. So now 16, so this is this, I'm just rewriting it down here. 16 times 2a to the 4/5 power. Okay? And now I'm going to write it as a radical. So 16 times, this would be the 5th root of 2a to the 4th. And if I wanted to, I could even go and clean that up just a little bit more. Equals, I'm just going to write it down here. So 16, I don't have to put that multiplication symbol because it's understood that it's being multiplied. 5th root. I'm going to apply this exponent to everything that's in here. So this would be 2 to the 4th, which we actually just did, was 16. And then a to the 4th, I just write as a to the 4th. And there you go. 64a, all of that to the 4/5 power, ends up like this as a radical. Let's do another one like that. That one was pretty ugly. Alright, I'm going to do one more just like that. Let's say we had this. 54y to the 2/3 power. Now again, if you see those parentheses, I want you to look at your denominator. I want you to ask yourself, is there a way I can break up my number so that it can be nicely broken up into this many pieces? Coffee. So, 54 cannot be nicely broken up into 3 pieces. Something where if you multiply it by itself 3 times, I'm going to get 54. Not going to work. However, I notice that 54, I can rewrite it as 27 times 2. And can't 27 be nicely broken up into 3 equal pieces? The answer is yes. So, I'm going to end up doing this. Okay? Whoops. There we go. All right. So, let's go ahead and take that 27, excuse me, and raise it to the 2/3 power. I can think of it like this. 27 to the 1/3 times 27 to the 1/3. So think to yourself, what's a number that I can multiply by itself 3 times and I get 27? The answer is 3. So 3 times 3, well, that gives me 9. So 27 to the 2/3 power is going to end up being 9. So I'm going to rewrite it down here. This is really like 9 times 2y to the 2/3 power. Okay? Let's keep cleaning it up. 9 times the third root of 2y squared. Okay, because remember this whole thing is being raised to that power. And then I'm just going to clean it up a little more. 9, the cube root of, remember this applies to everything inside, so 2 squared and y squared, so 4y squared. And you're done. When you have ones like this, it's going to take a little creative thinking. You have to look at your denominator and ask, is there a way I can nice and cleanly break it into that many pieces? What numbers can I break this up into in order to make it nice and neat and clean? Alright, so that's how you go into radical form. Now we're going to go the other way where we start with a radical and we have to put it into exponential form. Exponential means I should only see exponents going on. All right, and here we go. Let's start with this one. So let's say we had the fifth root of b to the third. Okay, now remember, when you have these, your index is your denominator, whatever exponent is next to that guy is your numerator. So I'm going to rewrite this. I keep the same base, numerator, denominator, and you're done. That one was easy. Let's try another one. This one's going to be a little more difficult. Okay. Third root, 27d to the fifth. Okay. Now, you need to be careful on this one because there's more stuff in the radicand. So I know that this would be my denominator, but you have to think, what's going to be your numerator? It's not going to be this 5, because this 5 is only applying to the d. Remember, if there's no parentheses around this, the exponent only applies to what's directly under. So here's how I'm going to write this. 27d to the fifth to the 1/3 power. Okay, I will be able, when I get to the final form, I'll show you why I would go back to this. Okay, so if you don't have parentheses, remember, this only applies to what's underneath, so I have to write it to the 1/3 power. Alright, so I can clean this up a little bit more though, because this 1/3, remember, it applies to everything that is inside the parentheses. So this is really like equals 27 to the 1/3 times d to the fifth to the 1/3. Okay, we actually just did 27 to the 1/3 power. We found out that that is 3. I'm going to write it down here. So 3, and then d to the fifth to the 1/3. Remember, if you have a power raised to another exponent, we multiply these guys. So this would be 5 times 1/3, which would be 5/3. So I can read it times d to the 5/3 power, and then I can just get rid of that multiplication symbol. Okay, so that is what you would get there. And if you think about it, I'm just going to write this off over here. I can actually kind of break these up. I can think of this as the third root of 27 times the third root of d to the fifth. Okay, and then what's the third root of 27? It's 3. And if I wrote this as an exponent, d to the 5/3, there it is. So kind of two ways you can do it. You can bring it out this way, or you can split it up and do it that way too. Okay, let's try another. Now this one, you can't really split up because, I guess you could. We'll maybe do it both ways. 4y to the 5th. Okay. Now, if you don't see a number here, understand that it's a 2. This is the square root. So there's a secret 2 right there. So if you only see the symbol with no number, just know that it's a 2. Okay? So, this, the whole thing is being applied to the 5th power. So I'm going to rewrite this as 4y to the 5 halves. Now you could leave it like that in theory, but I'm going to clean it up because I want to. This 5 halves applies to everything that is underneath. So this would be 4 to the 5 halves times y to the 5 halves. Okay? Now y to the 5 halves, that's pretty much as simplified as I can get. But I can simplify this more. And I want you to think of this. It's 4 to the 1/2 times itself 5 times. Okay? I'm not going to write it all out. So 4 to the 1/2 is the same as the square root of 4. So you could do it as 2 times 2 times 2 times 2 times 2. Which is 2 to the 5th power, which would give me 32. So 32 y to the 5 halves. Okay? Now, you could split this up. It would be a little ugly, but I'll just rewrite it anyway. You could write this as the square root of, and I could clean this up in here, 4 to the 5th power times y to the 5th power. And then, 4 to the 5th power. Hang on, let me grab my calculator. So then what you would do, I found 4 to the 5th power is 1024 y to the 5th. And then you would just you would write this in exponential form. So the square root of 1024 would be 32. And then we could just write this as y to the 5 halves. Okay, 2 ways you could do it. If you're more fond of breaking it up and then just kind of doing them separately like that, that's fine. Or if you want to bring it out first and then do them separately, that's fine too. I feel like I kind of like this one better, just so I can, I don't know, I feel like that works better for me. But if you like this way better, you are welcome to do it. Okay? Let's do one more. Let's do one more. This will be D. This will probably be the last one that we do for today. Alright. Let's say we had the 4th root of 256 a to the 8th. Now, notice no parentheses. There are no parentheses. So, you have to do this with the 8th, to the 8th power only being applied to the a. Okay? So, I'm going to do this. So this would be 256a to the 8th to the 1/4 power. Okay? So I can rewrite this as 256 to the 1/4 times, whoops, a, not 8, a to the 8th to the 1/4. There we go. Okay? So think to yourself, there's a number that multiplied by itself, I'm sideways, sorry guys. There's a number that multiplied by itself 4 times gives me 256. Now if you need to play around with that a little bit, that's okay. The answer is 4. This would be 4 times a to the 8th to the 1/4. Okay? And whenever you have an exponent being raised to another power, you do these numbers times each other. So this would be 4 times a squared, which I can just write as 4a squared. Okay? If you wanted to break it up beforehand, let's say you wanted to do it a different way. Let's say you wanted to break it up into the fourth root of 256 times fourth root a to the 8th. Let's say you wanted to do that instead. Because then you would see, okay, fourth root of 256, that would have to be 4 times, this would still be a to the 8th to the 1/4 power. And then you could still get back to 4a squared. Okay? So that's how you do it. There's kind of two ways that you can go about it. This way is more the way that your book was trying to do it. But if you're more comfortable with breaking it up this way, that's fine too. You know, whichever way works better for you, entirely your call. So I'm going to have you guys pause here. We're going to hop on over to IXL and do some practice.